Hello everyone, recently, D Robotics released its new generation, RDK S100 development board. This is the first robot development kit to achieve integrated computing and control. It with 80 TOPS of computing power, performance close to NVIDIA Jetson Orin series, Cerebral collaborative architecture, integrating 3 core modules, CPU, BPU, and MCU, supports a complete closed-loop process, from perception to decision-making to control. RDK S100 board, CPU, is a 6-core Cortex A78AE, providing up to 100 ks DMIPS computing power. BPU is based on the Nash architecture, providing up to 80 TOPS computing power, optimized for AI inference. The MCU responsible for real-time control tasks is a 6-core ARM Cortex or 5.2+, ensuring stable system response compared to the previous generation RDK X5. The overall computing power has increased by 8 times. Next, let's do an actual test. The kit includes a RDK S100 board, a power adapter, and user manual. The RDK S100 board have been pre-installed with an acrylic case, cooling fan and heat-sinked. It's ready to use immediately upon receipt. If this is your first time using this type of development equipment, you can flexibly configuring peripherals according to your usage scenario. For example, S100 does not have an integrated network card chip. If wireless connectivity is required, you can add an end-to network card and antenna. For those with AI vision processing needs, supports connecting USB camera, plug and play, suitable for rapid development and testing. For higher image quality or latency requirements, MIPI or CMSL industrial-grade cameras can be selected, but RDK S100 board does not have a MIPI provided by CMSL interface. A dedicated camera expansion board is required for connection to achieve a more stable visual acquisition effect. In addition, RDK also provides an MCU interface expansion board, suitable for users who need to expand embedded control or communication functions. It supports commonly used interfaces, such as Ethernet, CAN, FD communication, ADC, and WPN, providing more possibilities for complex projects. In terms of storage, RDK S100 board has built-in 64 GB NC space, sufficient to meet normal development needs. As you can see at the top, there's a classic 40-pin GPIO interface, common MCU interfaces. On the side are MCU interface expansion board interfaces, a 64 GB NC chip, a network card interface. On the side, there are 2 Gigabit Ethernet ports, 4 USB 3 ports, HDMI video port, a Quick Connect Type-C port, a power connector. You can see a camera expansion board interface and a SSD interface on the back. RDK S100 not only comes with abundant interface resources, but also supports flexible memory scheduling, allowing for resource allocation based on actual application scenarios. For AI algorithm inference tasks such as image recognition and visual processing, more memory can be allocated to the BPU first. For traditional computing tasks, more memory can also be allocated to the CPU, improving overall efficiency. Currently, RDK S100 has been successfully applied in multiple robotics fields, including bipedal robot, quadrupedal robotic dog, and robotic arm. For example, Unitree Robotics G1 humanoid robot utilizes the RDK S100 to achieve efficient full-body motion control. D Robotics provides a complete toolchain, includes official hardware acceleration support for mainstream AI models, MROS2 feature packs, 200+ open-source algorithms and application cases, and complete model tuning and deployment solution. Yum has further expanded its development resources, provide relevant development materials for offline large language models and visual multimodal large models. It has been successfully adapted to major language models such as DeepSeek and Google. Continuous updates ensure compatibility and performance optimization, helping developers efficiently deploy various AI applications. Now, let's compare the RDK S100 with Jetson Orin. From a hardware perspective, RDK S100 with better computing power, up to 80 TOPS, far exceeding the Jetson Orin Nano series, approaching the level of the Orin ONNX 8GB version, although its GPU performance is inferior to NVIDIA's architecture. It effectively compensates for this with BPU acceleration. Overall performance is comparable to the Jetson platform. Furthermore, RDK S100 integrates a quad-core Cortex-R5 MCU module, possessing better perception decision control, closed-loop capabilities, significantly enhancing its applicability in embedded robot control scenarios. In comparison, while the Jetson Orin ONNX offers superior performance, but it is more expensive, more suitable for high-end AI edge computing tasks. In terms of interface configuration, RDK S100 is closer to also significantly enhanced support for MCU control and industrial camera access. Its overall expandability is more suited to robot application scenarios. For developers seeking cost-effective alternatives, especially in the field of embedded robot applications, the RDK S100 is a new option that's definitely worth trying.